Type NMB cable is generally not permitted in industrial environments. The National Electrical Code, specifically Section 334.12 A1, addresses the limitations of using Type NMB cable. This section states that Type NMB cable shall not be installed where exposed to severe physical damage. Industrial environments are often characterized by the presence of heavy machinery, moving equipment, and the potential for physical damage to electrical wiring. Consequently, Type NMB cable is generally deemed unsuitable for these conditions due to its non-metallic sheath, which can be easily damaged. Alternative wiring methods are recommended for industrial environments to ensure safety and compliance with electrical codes. Firstly, conduit and wire offer robust protection. Raceways or conduits encase the wires, shielding them from physical damage and environmental factors. This method provides a durable and reliable wiring solution for demanding industrial settings. Secondly, Type MC, or metal-clad cable, provides mechanical protection for the wires contained within its metal armor. The metal sheath offers resistance to impact, abrasion, and other potential hazards commonly found in industrial environments. Thirdly, Type AC, or armored cable, is similar to Type MC cable but typically features a lighter metal armor. It provides a degree of mechanical protection while offering flexibility in installation. In addition to restrictions in industrial environments, the NEC also addresses the use of Type NMB cable in dropped or suspended ceilings. In most cases, Type NMB cable is prohibited in these spaces. However, an exception exists for family dwellings, where it is permitted if the cable is installed in a raceway or conduit. This exception acknowledges the generally less demanding conditions found in residential settings compared to industrial environments. Understanding the specific requirements and limitations outlined in the NEC is crucial for ensuring safe and compliant electrical installations. When working in industrial environments, careful consideration must be given to the potential hazards and the need for robust wiring methods. The choice of wiring method should be based on a thorough assessment of the environment, the anticipated loads, and the applicable electrical codes. Utilizing conduit and wire, Type MC cable, or Type AC cable provides enhanced protection and ensures the long-term reliability of the electrical system. It is essential to consult the latest edition of the NEC and local electrical codes to ensure compliance with all applicable regulations. Regular inspections and maintenance are also crucial for identifying and addressing any potential issues with the electrical system. These measures help to maintain a safe and reliable electrical infrastructure in industrial environments. Type NMB cable is a common type of electrical wiring used in residential buildings. It consists of two or more insulated conductors wrapped in a non-metallic sheath. The B in NMB indicates that it is rated for 90 degrees Celsius or 194 degrees Fahrenheit, although the ampacity is based on 60 degrees Celsius or 140 degrees Fahrenheit or 75 degrees Celsius or 167 degrees Fahrenheit depending on the conductor size. While NMB cable is suitable for many residential applications, it is not appropriate for all environments. As previously mentioned, the NEC restricts its use in industrial settings and in certain types of ceilings. The primary reason for these restrictions is the vulnerability of the non-metallic sheath to physical damage. In industrial environments, heavy machinery, moving equipment, and other activities can easily damage the cable, potentially exposing the conductors and creating a safety hazard. Similarly, in dropped or suspended ceilings, the cable may be susceptible to damage from ceiling tiles, light fixtures, or other equipment. When selecting wiring methods for industrial environments, it is essential to consider the specific conditions and potential hazards. Factors to consider include the presence of corrosive substances, the potential for moisture exposure, the range of operating temperatures, and the likelihood of physical damage. Based on these factors, appropriate wiring methods can be chosen to ensure the safety and reliability of the electrical system. Conduit systems offer a high degree of protection for electrical wiring. Rigid metal conduit, intermediate metal conduit, and electrical metallic tubing are commonly used in industrial applications. These conduits provide a robust barrier against physical damage, corrosion, and moisture. The wires are pulled through the conduit after it is installed, allowing for easy access and modification. Type MC cable is another popular choice for industrial wiring. The metal sheath provides excellent mechanical protection for the conductors. Type MC cable is available in a variety of sizes and configurations, making it suitable for a wide range of applications. Type AC cable, also known as BX cable, is similar to Type MC cable but typically features a lighter metal armor. It offers a balance of protection and flexibility, making it a good choice for installations where space is limited. In addition to the specific wiring methods used, proper installation practices are essential for ensuring the safety and reliability of electrical systems in industrial environments. All wiring should be installed in accordance with the NEC and local electrical codes. Qualified electricians should perform all electrical work. Regular inspections and maintenance are crucial for identifying and addressing any potential issues. By following these guidelines, it is possible to create a safe and reliable electrical infrastructure in even the most demanding industrial settings. The NEC is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect the latest advancements in technology and safety practices. The NEC is adopted by many jurisdictions as the basis for their local electrical codes. It is essential for electricians, engineers, and other professionals involved in electrical work to be familiar with the NEC. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It provides detailed requirements for the design and installation of electrical systems in residential, commercial, and industrial buildings. The NEC is organized into chapters, articles, and sections. Each section addresses a specific aspect of electrical safety. The NEC is a complex document, but it is essential for ensuring the safety of electrical systems. By following the requirements of the NEC, it is possible to minimize the risk of electrical shock, fire, and other hazards. In addition to the NEC, other organizations and agencies also provide guidance on electrical safety. OSHA, for example, sets and enforces workplace safety standards, including those related to electrical hazards. ANSI develops and publishes voluntary consensus standards for a wide range of products and services, including electrical equipment. AEE is a professional organization for electrical and electronics engineers. It develops and publishes standards related to electrical power systems, telecommunications, and other areas. Staying up to date on the latest electrical safety standards and best practices is essential for all professionals involved in electrical work. By working together, we can create a safer electrical environment for everyone. Electrical safety is a shared responsibility. Everyone has a role to play in preventing electrical accidents. Homeowners, business owners, and workers all need to be aware of the potential hazards and take steps to protect themselves and others. Simple steps, such as checking electrical cords for damage, avoiding overloading circuits, and using ground fault circuit interrupters in wet locations, can significantly reduce the risk of electrical shock and fire. Electrical safety is not just a matter of following the rules. It is about developing a safety mindset and making informed decisions about electrical work. By prioritizing safety, we can create a safer world for ourselves and future generations. Remember that electrical work can be dangerous. If you are not qualified to perform electrical work, always hire a licensed electrician. An electrician has the training, experience, and tools necessary to do the job safely and correctly. Never attempt to repair electrical equipment or wiring unless you are qualified to do so. Working with electricity can be fatal. Always disconnect power before working on electrical equipment or wiring. Use appropriate safety gear, such as rubber gloves and insulated tools. If you are unsure about anything, ask a qualified electrician for help. Electrical safety is everyone's responsibility. Let's work together to prevent electrical accidents and create a safer world. In summary, the use of Type NMB cable in industrial environments is generally prohibited due to the potential for physical damage to its non-metallic sheath. Alternative wiring methods such as conduit and wire, Type NC cable, and Type AC cable are recommended for industrial applications to provide enhanced protection and ensure compliance with electrical codes. The NEC provides detailed requirements for the safe installation of electrical wiring and equipment, and it is essential to consult the latest edition of the NEC and local electrical codes to ensure compliance with all applicable regulations. Regular inspections and maintenance are also crucial for identifying and addressing any potential issues with the electrical system, helping to maintain a safe and reliable electrical infrastructure in industrial environments. When considering electrical installations, it is important to remember several key concepts. Firstly, proper grounding is essential for safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Secondly, overcurrent protection devices such as circuit breakers and fuses are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when it exceeds a safe level, preventing damage to equipment and reducing the risk of fire. Thirdly, wire size must be appropriate for the amount of current it will carry. Using undersized wire can lead to overheating, insulation damage, and even fire. The NEC provides tables that specify the minimum wire size for different ampacities. Fourthly, electrical boxes must be properly sized to accommodate the wires and devices they contain. Overcrowding electrical boxes can damage the insulation and the wires and create a safety hazard. Fifthly, all electrical connections must be tight and secure. Loose connections can cause arcing, overheating, and fire. Use appropriate connectors and tools to ensure that all connections are properly made. Sixthly, electrical work should only be performed by qualified individuals. Electricians undergo extensive training and apprenticeship to learn how to install and maintain electrical systems safely. If you are not qualified to perform electrical work, always hire a licensed electrician. Seventhly, regular inspections and maintenance are essential for keeping electrical systems in good working order. Inspect electrical cords, outlets, and switches for damage. Replace any damaged components immediately. Test ground fault circuit interrupters regularly to ensure that they are functioning properly. Eighthly, be aware of the potential hazards associated with electricity. Never touch electrical wires or equipment with wet hands. Avoid using electrical appliances near water. Never overload electrical circuits. If you are unsure about anything, ask a qualified electrician for help. By following these guidelines, it is possible to create a safe and reliable electrical system.